All right, if you go ahead and open up section 2.2, histograms, frequency polygons, and time series graphs, and if you scroll down to this first example, it says here are the heights to the nearest half inch of 100 male semi-professional soccer players. Heights are continuous data, and it gives us some values here and tells us it basically tells us where the boundaries are going to be and then shows us this relative frequency histogram, but it doesn't really tell you how to get that. So I'm going to sort of go step by step explaining this example from the book. And I have copied, just sort of, to speed things along a little bit, I've copied these values into Statcrunch, and I literally just typed in the values. It looks like it goes from 60 to 74. And if I were going to just create a frequency chart without worrying about grouping values, these are all possible values I could have for half inches between 60 and 74 inches. So somebody is 5 feet tall, that's a professional soccer player, 60 inches. And there's only one person that's 5 feet tall, one person that's 60 inches, 60 and a half inches. Let's see, now we go, oh, well, there are 2 people that are 61 inches. So I'll go ahead and hit 2 there. It's just, the frequency is just a count. One person that's 61 inches. There are 0 people that are exactly 62 or 62 and a half, 63. 63 and a half, we've got 3, etc. So if I go ahead and count these, 1, 2, 3, 4, 5, 6, 7. And do the rest, 1, 2, 3, 4, 5, 6, 7, 8. I'll sort of speed this up and quickly do this, but all I'm doing is counting each number of values. There are 0, 64, 5, 65.5, but there are lots of 66s. Okay, so this would be our frequency. This would be our frequency chart without putting our values in bins. And it's a little bit, well, it is shorter. It's definitely shorter, but I have like 29 values here. It would be nicer to have a little bit smaller table. It's easier on our eyes. And so what we can do, as it shows us in this book, is just to basically find some boundaries, and it looks like it has like 1, 2, 3, 4, 5, 6, 7, 8 bins instead of trying, or intervals instead of trying to give all 30 values. So it says, hey, we can take, and it tells you how to find a class interval and to figure out that it's going to be about 2 units wide, etc. All of this stuff that you see right here, it's just a rule of thumb. It's not, it says you choose 8 bars. Well, if you said, well, so-and-so says choose 6 or 8 or 7, that would be fine too. So in other words, it's not that you always have to have 8 bars in a frequency chart here, or a frequency table, but the author is just showing you, let's suppose you choose 8 bars, this is a good idea. And if you have if your data goes to 1 decimal point, then it's always nice to actually have your intervals go to 2 decimal points, and that way you can kind of go around. For example, it starts at 60, but if we started at 59.95, then we go to the next interval, we can count 60 in that interval. So what I've done here is I've just recreated another frequency table, except this time having intervals. Now I'm going to count everything that's between 59.95 and 61.95. So these are these values that I've highlighted. 1, 2, 3, so there are 5 of those values. Next I have, let's see, 61.95 to 63.95. There we go, those are those values, so that would be 3. Moving right along, we have 63.95 up until 65.95, that's 15. And if I add all of these up, I should get that there are 100 values. Let's see, 8 plus 55. 8 plus 15 is 23, 63. This becomes 80. Plus 20, it's 100. So the total frequencies we have of all the values is 100. So this makes it really easy to see how you would find the relative frequency because it's out of 100. The relative frequency, if I wrote in a fraction, is just 5 out of 100, which is in decimal terms 0.05 and in percentage terms 5%. So I can do this for each one of my values. 3 out of 100 are in this frequency, 0.03 or 3%. And of course, our values should add up to 100%, and you can see that here. That's for the relative frequency. Cumulative would look a little bit different. It would say, in our intervals, it would say something like, I don't know, 61.95 or below. And then the next one would be 63.95 or below, etc. So you're counting all of them up, 65.95 or below. So my cumulative frequency same for the first one, there's only 5 there, but for the next one I'm counting the 5 and the 3, so now we have 8. And for the next one I'm counting the 5, 3, and the 15, so that's 23. And then we add another 40, we've got 63. We add another 17, we've got 80. Add another 12, we've got 92, 99, 100. All right, and our cumulative relative frequency looks like the following. We would have 5%. Are 61.95 or below. We would have 8%, are 63.95 or below, etc. In other words, we're adding up the percentages as we go along. And in this case, again, because it's out of 100, it's pretty easy to see our percentages. For cumulative relative frequency, you'll always end with 100 because by the time you get to the highest value, you'll say that value or below, and you'll include all of the values. Okay, so I did all of that, even though I did this on a spreadsheet. Really, I did it by hand. I could have just been writing that on a piece of paper. I didn't ask my computer to count for me or do anything. And so I want to show you a couple of tricks while we're in Statcrunch. I've entered my variables. It's all entered my data all into variable 1. I can hit graph, histogram. It's telling me I have different variables, but that's just because I've put in tables here. Really, the only variable I have is that variable 1, which is where my data is. And I don't want to do group by. I don't want to do where. I want to do a frequency chart. And I could say, tell them where I want the bins to start with. The bins are the same thing as the intervals, like how do you want to shorten, put these into 8 bins or something like that. Let's say, and I'll go ahead and I'm going to click value above bar. Let's see, you have other options. I've got markers. I could show the mean, the median, etc. So I'll go ahead and put those in. Why not? It's not necessary for that problem, but if I hit compute, what I can see is that first of all, my mean and my median are very close together. It's almost symmetric. We can see it's not quite symmetric, but it's almost symmetric. And here are the values. So in fact, yeah, it looks like that by counting by hand, I pretty much got the same values as the computer did. And in fact, I didn't even tell it how to bin, but it still binned the values pretty close to mine. So that's a frequency histogram. But I could also, there was another option in here, was to do a relative frequency histogram. And again, I'll put the value above the bar, compute. And what I see here is, in fact, they're completely the same histogram if we look at it and don't even look at the numbers. But the difference here is on the left, I have a relative frequency histogram with percentages, and on the right, I have just a frequency histogram. So you can create, if you're using, you can create a frequency chart for both categorical and for quantitative data. Or however, you would create a bar chart if you were doing something like eye color, and for values like height, as we have here for heights of soccer players, the bar chart would be just touching. We have continuous variable on the bottom, which is height, and it would look like a histogram. So actually, I'm going to do this one more time because there was an option to put the normal distribution right over it. So let me see if I can just do that. And you can see there's the normal distribution curve, and it's approximately normal, right? Not quite, but approximately normal.